The purpose of chlorine disinfection is to inactivate bacterial pathogens from water sources. This method is commonly used in drinking water plants, pools, and rural drinking water systems because of the widespread availability of chlorine. When chlorine is added to water, it reacts with a variety of substances like organic and inorganic material and metals before disinfection begins. The remaining amount of chlorine is known as total chlorine and is the concentration after the chlorine demand is met. This branches off into free chlorine and combined chlorine. Free chlorine is the most important as it is the concentration of chlorine available for disinfection. Chlorine comes in several forms like powder, liquid, gas, and tablets. In this system, we'll be using calcium hypochlorite tablets to increase the chlorine levels. Calcium hypochlorite reacts with water to produce calcium ions, hydroxide ions, and hypochlorous acid. Hypochlorous acid dissociates into a hydrogen ion and a hypochlorite ion. Free chlorine levels are determined by the amount of hypochlorite ion and hypochlorous acid. However, hypochlorous acid is a much more effective disinfectant. A complete reaction occurs at a pH between 6.5 and 8.5, and disinfection overall is more effective with lower pH.
Residual chlorine is the amount of free chlorine left in water after disinfection has occurred. This value can be an indicator of clean drinking water and is what we are testing for in the experiment performed. The World Health Organization has set a standard of a minimum of 0.2 milligrams per liter for potable water.
Our chlorination system is displayed here, running continuously with pool water and no chlorine tablets. The system is equipped with two valves, one for the primary flow and one for the flow into the chlorination system, which is shown here without a cap to observe water flow. When the chlorination valve is closed, the volume of water exposed to chlorine is restricted, and the overall residual chlorine of outcoming flow is decreased.
For our experiment, we will be measuring the amount of residual chlorine in tap water and then the amount after the water runs through the system. The original amount of residual chlorine is 0.21. This is the system we have set up to run the tap water through so it can be chlorinated.
We've set up a small volume of tap water to run through the system to show proof of concept that the system increases chlorination levels. A single calcium hypochlorite tablet has been placed in the tablet tube.
We have designed this tube in a way so that it holds the chlorine tablet in place while also fitting in the larger system, making it easily accessible for people.
Using free chlorine reagents, we tested the water again after running through the system. The reagents react with available chlorine, turning the sample a color of red or pink. The sample is placed in a chlorine meter, which can read total or free chlorine, depending on the reagents used. The results of the chlorine meter test show that the residual chlorine has increased from 0.21 to 0.27 parts per million, proving that the system is capable of increasing chlorination levels.
"20 seconds later."
Like the SpongeBob.